So for question 15, they're giving you question of log and question of exponential. So for the first part, show this fx is 1 to 1 algebraically. So they already determined for you. You only can use algebraic method. You cannot use graphical method. So what's mean by algebraic method? What have we need to calculate here is we need to find out when we substitute x1 into the function and x2 into the function, we try to find out our x1. Is it our x1 only equals to only x2 one answer, or we have two answers? If you have two answers, means this function cannot one to one. If only get x1 equals to x2, then only this function is one to one. So we start substitute. If we have x1, it will be ln 2x1 plus 3. If we have a x2 here, means our function here will be ln 2x2 plus 3. So the working after this is going to show how you find your x1, how you list out all these functions, simplify it to get x1. So when I want to simplify this ln, it is an equation. You can see it's an equation where both sides also single log. So when you have both sides single log, means that we can equal to the item only. So when we equal to the item, it is equal to 2x1 plus 3. 2x2 plus 3. Or another way we can see here is when we unlock. When we unlock this ln, the base e will go to the opposite here. E to the power of ln, they also can be simplified. So they still get to the same status here. 2x1 plus 3 equals to 2x2 plus 3. Move our 3, it will be minus. Then move our 2, it will be divided, and leaving x1 equals to x2. So once we get this result, means that this function is one-to-one function. Okay, so this is our algebraically method concept. Let x1 equals to x2, substitute and simplify. Simplify our x1 to prove it. This is one-to-one when we get this result. Okay, so we continue. They say for question B, find the composite fgx and gfx hence. So based on the result, we have to conclude something about this result. Okay, so we find it out first. What is our fgx? So substitute gx inside here. And take this and substitute into the fx, where the place of x will be substituted by ex minus 3 over 2. So it will be ln 2, substitute this. So we try to simplify it. So multiply 2 divided by 2, it will ln ex minus 3 plus 3. So simplify ln ex. So x ln e. So ln e equals to 1. So we get x. So another question here, gfx. So we substitute fx inside ex minus 3. So our fx here is ln 2x plus 3. Is it? Ln 2x plus 3, okay? Substitute this ln 2x plus 3 into g. So into this place, into. So here is ln 2x plus 3. So substitute inside x here. So we can notice that e to the power of ln, we can simplify. After we simplify, we get 2x plus 3 minus 3 over 2. And then plus 3 minus 3 also can simplify. And then 2 divided by 2 also can simplify. Lastly, we also get x. So therefore, when we composite, we get x. We have the relationship here. We have we have important concept here. When we composite, we get x means what can we conclude? These two different functions, gx and fx, they are inverse to each other. Okay, so we can see these two different function they were inverse to each other because they get the composite answer as s. Okay, so this is our composite concept and get to the answer of x. Simplify the exponential. And this is our final answer. So you have to be careful here. Our conclusion is not gfx and fgx inverse to each other. It's not the composite inverse to each other. It's the individual function. It's an individual function inverse to each other. When we get their result, when they composite together, we get x. So you don't misunderstand this. If you're writing gfx, fgx inverse to each other, there definitely is a wrong things. It's not composite. It's not composite inverse to itself. Is the individual function here is inverse to itself. After we do the composite, they get result x. Okay, so once we realize these two individual functions, even they are different function, they're still in the special relationship inverse to each other. So that's why question 15c here, they ask us to sketch these two functions on the same axis and state their domain and range. State the domain and range for fx. So we sketch first. Okay, so we sketch first. So we have to know that we need to use the concept of refraction. We sketch fx and we refracted out this gx because they are inverse to each other. It's not the concept we're going to draw them independently. Okay, so we set up our x-axis and y-axis correctly. X-axis, y-axis. So we are going to draw out function fx and refracted to gx. So before I go in to draw our function fx, I need to know what's the domain and range. So we see our function ln 2x. Function ln 2x minus 3. Ln 2x plus 3. Okay, so we can see the domain. Our ln function is special case, so we need to do some calculation. It have to greater than 0, so our x is greater than negative 3 over 2, means our domain of the function here is asymptote negative 3 over 2 to infinity. So when we see this domain, we know that our log is going to the right hand side because negative 3 over 2 to infinity. So it's asymptote happen at here, which is x equals to negative 3 over 2 to infinity. And we see this log, so going to the right hand side. So basically the shape will be like this. Is it going to terbalik or not? Then we see our log here is positive, no need to terbalik, then ln is okay, so it just will shoot up. Okay, so it will shoot up to the right hand side. So here adalah sini adalah kaki log dan dia akan shoot ke atas. So bila kita shoot ke atas, kita kena hati-hati, either it will be above reflection axis or below the reflection axis. So that's why you have to find out what's your y-intercept here. You cannot undershoot or you overshoot. When your x equals to 0, our y will be ln 3. So ln 3 will be equals to, so you can use your calculator and test your point. Ln 3 will equal to 1 point something. So when you're going to shoot up, you already 1 point something here, ln 3. So definitely it will go above axis of symmetry. So this is how we draw. This is graph log, dan dia akan shoot up. So this is our fx. Y-intercept ln 3. So catat asymptote, catat y-intercept, and don't forget we have another x-intercept here. So for x-intercept, we will let y equals to 0. When y equals to 0, it will be ln 2x plus 3. Then unlock your ln, it will e power of 0, 2x plus 3. So 1 equals to 2x plus 3. Move your 3, it will be minus 3. So our x will equal to negative 1. So this graph, for this log graph, it has x-intercept, it has y-intercept, so only is finished. Then kamu lipat dan awak pantulkan graf tersebut. So lipat kertas dan pantul supaya awak akan dapat graf yang lebih simetri dan tepat di tempat. So tepat di tempat maksudnya asymptote, bila awak dapat reflection, it will occur at here. This is what you get. And when you can see your reflected graph here, kesan reflected tu awak berlaku di sini. So kita catat. Awak ada kesan. So dia tak akan agak-agak terlebih ke bawah ke, jadi tak simetri pula. So, dah nampak kesan graf awak dan awak ikut kesan graf awak untuk dapatkan GX tersebut. So don't forget label. Label is horizontal asymptote. The intercept here ln 3 and intercept here negative 1. And the origin 0, 0. Okay. After we reflection, don't forget they said find the domain and range. So the range, so I come back to here, range of our function, range untuk log bukan special case, so they're negative infinity to infinity. So how we get these 5 marks? The first one is how we see your fx, diagram of fx, whether you're doing your intercept correctly and asymptote correctly. Second marks, we're going to see your refracted, whether you're doing your GX correctly with your asymptote and the place of intersection here correctly. Lastly, only label. Label all x-axis, y-axis, reflection, origin, everything. And domain and range both give you one answer, 1 marks.